Okay, so for part D, it says at time t, at t equals 10, the population of the colony has doubled in size from its initial value. Now, its initial value was 1200, if we remember here, 1200. So double its initial value is 2400. So for part D, I want to find the I want to find the K, where P is 2400. So K is 2400 equals 1200K, I don't know, all over K minus 1200, I still don't know. And then e to the negative t over 5, it says at t equals 10. So it's negative 10 over 5, or obviously just negative 2, plus 1200. How do I solve this? Just use your calculator. And I've already done it, guys. Nsolve, put in this equation, comma k, and finds me k, which is 2845.35, 2845.35, but it says 4 significant figures. So because it's 4 significant figures, I will say 2845. Okay, part E. He then says, so these, I think part D there is actually, that's an easy question, guys. It's only 3 marks. It's actually not only 3 marks, it is 3 marks for a fairly easy question. This one is hard, yeah, for sure. But this one's not difficult. And this one's not difficult either once you know how to use your calculator. So it says find the value of t when the rate of change of the population is at its maximum. Now you could find because it's where dp dt is at its maximum. So you could find where this is at its maximum, but be clear, you have then found p, and you'd have to sub that p into this equation to find t. That would work. Or the easier way, the way I'm going to do it here, is you actually just sketch dp dt. So it says the value of t when the rate of change of the population at its maximum. So max of dp dt is at t equals, so watch this. So I have sketched this function here. You can't see it just because the zoom. So I'm going to click zoom fit. Okay, that's not bad. Let's zoom out a little bit more. Okay, so this is the function, and this is it's a logistic function, they're called. It is a typical kind of population model. It starts increasing quite rapidly at the start, and then slowly starts to decrease and reaches its a limit, and where the population doesn't get any bigger. But where is it increasing most rapidly? Well, it's actually the point of inflection. It's over here somewhere. So you could actually find the second derivative, etc. But on this, when the second derivative equals 0, you could do that. But on this calculator, you can actually just sketch the first derivative. Watch this. Not this. I'm going to do tab, and here I'm going to sketch the first derivative ddx of f1 of x. Press enter, and he actually gives me the first derivative, and it's the maximum of this function, which I think is going to be here somewhere. So we're going to do menu, analyze graph, maximum. It asked me which graph, so it's this graph, lower bound here, upper bound here. So the maximum is at 1.5782. 1.5782. Note, guys, when I'll put approximately equal to 1.58 here. But note, when I sketched this function, look, I've subbed in the value of k that we found. And it was this one, 0.35, that I subbed in. You could also sketch the second derivative. I may as well do that while I'm here. Get the second derivative, this second derivative here, Again, it's f1 of x. There we go. The zoom now is very much not what I'm looking for. So let's zoom in down here. But you'll actually see where the second derivative is 0, and I'll do an analyze graph 0 here, lower bound, upper bound, it's the same, it's 1.5782. So where the second derivative is 0 is where the first derivative is at a max, which is where the rate of change of the population is at a maximum. So as I say, like that question, it's certainly not it's not easy to get your head around, but it's a very easy 3 marks once you know how to use your calculator properly and you realize you're trying to find the maximum of dp/dt and you have a GDC. Okay, that's it, guys. That's paper 2. So I'll see you in the next video, whatever that is, maybe paper 3.